Okay, this lesson we're going to be talking about radicals and how to simplify them. So a reminder, a radical is made up of a couple parts. We have the most common one we know is the square root, where there's no number written right here. But there are other types of roots besides just a square root. Use little letter n to represent. This is called the index, which it tells you what root. So if it's a 2, it's square root. If it's a 3, it's a cubed root, etc. Now, a reminder, put this over here. If there's no index specified, if there's no little number written there, then that's an implied square root. So if we just had that root of x and nothing is written right there, no index, that would be the same as saying if we had a little 2 there. That's the same as the square root of x. Okay, then we have this root symbol here is called the radical symbol. And then we have whatever we're taking the root of is the radicand. And then this whole thing together is the radical, with the index, the radical symbol, and the radicand. Okay, and again we have some different roots. So we do have, when we're talking about square roots, we have to talk about perfect squares as well. The perfect squares are when you take a square root of a perfect square, it equals an integer, meaning it's not an ugly decimal. So square root of perfect squares give us an integer. Or in other words, the product, well, if I could type, or if I could write the product, here we go. Product means multiplication of a perfect square, or of a number multiplied by itself, or in other words, squared. So, for example, like 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, 9 is a perfect square, and so on. So these are perfect squares is an infinite number of perfect squares, right? If you just keep squaring numbers. We're going to look at the first 10 perfect squares just to get used to. But any number squared will give you a perfect square. And etc. They go on. But these ones down here, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, those are perfect squares. And so we can use the product rule for square roots to help us simplify square roots. So the product rule says if we have 2 numbers that are being multiplied underneath a square root, then we can split up that multiplication and have the square root of 1 times the square root of the second. So for example, if we have the square root of 12, we could write that as 4 times 3, square root of 4 times 3, because 12 is 4 times 3. And then since we have a multiplication of 2 numbers inside a square root, we could use our product rule and split that up and have it be square root of 4 times the square root of 3. Okay, so that's using the product rule. And so when we're also simplifying square roots, it's going to be helpful to find the largest perfect square. So one of these numbers up here, that the radical is divisible by, that radicand, that number under the square root, can go into, because square roots of perfect squares can be evaluated using the product rule, meaning if we have the square root of some number squared, that's the square root of that number times itself, which is just going to equal whatever that number is with no square root. Okay, or in other words, if we remember, square roots and squared cancel out. They're the inverse of each other, so that's why we'd be left with just whatever that radicand is. So for example, if we had the square root of 16, 16 is a perfect square, which is the same as saying 4 squared. And so that square root and the squared would cancel out, and we'd just be left with 4. So the square root of 16 is 4 with no square root. When you take the square root of a number of a perfect square, that square root goes away. All right, so let's do some examples of simplifying. And so whenever we have a number out in front and there's no operation in between that 2 and that square root there, that's always an implied multiplication. We're going to worry about that 2 at the end. We'll multiply it by our final answers. But right now we're just going to focus on this square root of 25. And so really the most efficient way is just to go through your perfect squares. Oh my goodness. Your perfect squares. Just to see what 75 is divisible by. So just start going through. Dividing by 1 isn't really going to be helpful, so I would just start with 4. So do 75 divided by 4, see if that works. 75 divided by 9, see if that works. And so on. And we can keep going until we find a perfect square that can go into 75 nicely. And 25 is a perfect square that can go into 75 nicely. So we can rewrite this now as a product. So 25 times 3 gives us 75, right? We just wrote it as a multiplication problem. And so now we can use the product rule that says if we have the multiplication of two numbers under a square root, we can split it up into two separate square roots being multiplied. So the square root of 25 times the square root of 3. And now we can look at each of our square roots and see if we have the square root of a perfect square, which 25, that was our whole goal, was to find a perfect square that could go into it. So square root of 25 will give us 5. So we'll have 5 with no square root, and then times the square root of 3. And we just double check if we look at the square root of 3, if we go through our list of perfect squares. There's no perfect squares that can go into 3. Again, 1 is not going to be helpful when we're simplifying, but 4 is already bigger than 3, so there's no perfect squares that can go into 3 nicely, which means we're stuck with the square root of 3 in our final answer. And so now we have this 2 and the 5, 2 times 5, that are both outside of the square root, so we can multiply those together and have 10 square root 3 as our final answer. Okay, and let's do another one, letter B. So letter B, this time there's no number out in front. We have to worry about multiplying at the end, which is cool. And now remember with letter B, it's helpful to find the largest perfect square that can go into that number, just because that means you'll only have to use the product rule once. It's okay if you get a smaller perfect square. That just means you'll have to do some extra simplifying steps. So I'm just going to show you what I mean by that. So if we had 500 and you were just going through your perfect squares to see what could go into 500, the first one you would find is 4. That 4 can go into 500. So we would split that up as 4 times 125, and then we can use our product rule. So square root of 4 times the square root of 125. Square root of 4 is 2. You can also do square roots in your calculator if you don't remember the perfect squares. If you hit the second button and then the x squared button, that square root symbol pops up, then you just type in a 4, hit enter, it'll tell you square root of 4 is 2. So you can always use your calculator to double check. So we have 2 square root of 125. But now looking at 125, if we go through our list of perfect squares again, there is still perfect squares that can go into 125, which means that can be simplified more. So if we go through our list, 25 is a perfect square that can go into 125. So now we have this 2 out in front. We don't want to forget about it. Then we have square root of 25 times 5. Use our product rule, split that up. And then we know 25 is a perfect square, so if you want to check in your calculator, you do second x squared, type your 25, that gives us 5, times square root of 5. And if we look at our square root of 5, there are no perfect squares that can go into 5 nicely, so we're stuck with it, and so we're left with 10 square root 5. Okay, so that's one way you could do it, again, where you just go with whatever the first perfect square is that you find that can go into that number. However, if you tried to find the largest perfect square, 100 is a perfect square that can go into 500. 100 times 5. Then using our product rule, And then square root of 100 is 10, and we're left with our 10 square root 5. So you'll see either one gives us the same answer. It's just a little less work if you find the largest perfect square right off the bat. But if you don't do that and you just start going with whatever the first one is that you find, that works too. You will get to the same answer. You'll just have to do some extra simplifying. So either way works, just whatever way makes the most sense, whatever way you get to first is okay. All right, so I want you guys to try letter C and letter D. So letter C has this number out in front. Make sure you don't forget to multiply by that at the end. And then remember, you're always trying to find a perfect square. So 4, 9, 16, 25, one of those that can go into whatever's under the square root. So go ahead and do C and D. All right, and now we're just going to have some quick check questions and a self-assessment, and then bring any questions you have to the Google Meet.